resonance. So this word comes from a word that means to resound. So when an object is forced into vibrating at its natural frequency. And we'll talk about what the natural frequency is in just a minute. Alright, but when that happens, it creates a louder sound before because more particles are moving. Essentially, you've set up a standing wave within the object. So this is a type of forced or driven simple harmonic motion. So when we see SHM next semester, alright, we might come back to resonance. Okay, so let's talk about natural frequency.
What's her talent, bartending?
You may remember this from Miss Congeniality. Alright, so, turns out you can also break glass with sound. The best part of this is the look on the guy's face. High speed and then slowed down so you could actually see it. And here's a side view. And because you can't do it just once, it is science after all. So now we should actually talk about what was happening there. So pretty much every object will vibrate if you hit it or drop it. There are frequencies at which every object tends to vibrate, and those are based on the materials and the shapes and very complicated material properties. So musical instruments take advantage of these natural frequencies. They are built so they vibrate at sets of frequencies that sound good together. So that's why wind instruments have a certain length and the holes are in certain positions. And we'll deal with standing waves in a column of air in our lab and in another video lecture. All right, but so those frequencies that sound good together, remember when we talked about beats, we talked about intervals. So those intervals that sound nice are designed into the instruments. So some instruments, you can actually change the natural frequency, say a trombone. Okay, so if you take the slide and you extend it, you can actually change the length of the air column and therefore change the set of natural frequencies that it plays at.